Hey everyone, Mr. Kaczynski here. Got the culmination of section AA factoring from IXL's Algebra 1 for you. Skill TAH is factoring polynomials. Do not bother with this skill if you haven't mastered all the other skills leading up to it. It's going to be trouble for you if you do. So I think I've picked out a pretty good sampling of questions that give us the idea of everything. So here's one that appears a lot. It's the difference of two perfect squares. U's a perfect square, it's square root, or u squared is a perfect square, its square root is u. And 16 is a perfect square, its square root is 4. So whenever we have the difference of two perfect squares, we can factor it like this. It's called the sum and difference pattern, u plus 4 times u minus 4. Although this one down here on the bottom doesn't fit that pattern, it's not a perfect square minus a perfect, well, it actually is a perfect square minus a perfect square. But the thing we also need to notice is that they're both divisible by 9 first. So that would give us 16c squared minus 1. So after we factor out the GCF, then we can use the sum and difference pattern, 4c plus 1 times 4c minus 1. All right, so that was one of our special product patterns. Here's another one. The beginning and end terms are perfect squares, so maybe this fits the square of a binomial pattern. Let's check. Okay, the square root of 4h squared is 2h. The square root of 1 is 1. When you multiply 2h times negative 1, you get negative 2h. Doubled is negative 4h. And that last part's got to be true for this to be factored like this. If that was anything other than 4h, we'd have to use a different method. All right, so that works great there. It's not going to work here because 32 is not a perfect square. However, all three terms are divisible by 2, so let's start there. So let's go 2 times 16x squared plus 8x plus 1. And now we've got a trinomial that does begin and end with a perfect square, and the middle term is double the product of their square roots. Let me show you how. So 2 times 4x plus 1 squared. Square root of 16x squared is 4x. Square root of 1 is 1. 4x times 1 is 4x, doubled is 8x. So that is a perfect square trinomial. It can be factored like this. All right, so there's our two special cases that we learned patterns for. Next, we're going to move on to grouping. Okay, so grouping, just like it sounds, you group a couple of the terms here. So I'll take and group these first two terms, and I'm going to group the second two terms. The first grouping has a greatest common factor of 7u. So I'm going to factor that out. 7u times v is 7uv, and 7u times 2 is 14u. The second grouping are both divisible by 8, so I'll factor that out. 8 times v is 8v, and 8 times 2 is 16. So there we can pretty clearly see our factorization. 7u plus 8 times v plus 2. Okay. The second example of factoring by grouping is tougher. Number one, you've got a lot of variables, well, two variables instead of extra powers as well, and there's a greatest common factor of all the terms. However, the first thing I am going to do is grouping again. So I'll take the first group, or the first two terms, and group them together. This middle negative sign makes things a little bit tougher too. I'm going to group that into the second grouping. All right, in the first group, they have a greatest common factor of 3 and q squared and p. They're all divisible by those. When I factor that out, I'm left with actually a much simpler expression, q plus 2. The second grouping, they're both divisible by negative 5. And when I factor that out, oh, actually more than that, negative 5q squared. And when I factor that out, I'm left with q plus 2 again. All right. So what's our factorization here? 3q squared p minus 5q squared times q plus 2. But wait, there's more. That green factor, that has another common factor that can be factored out. Q squared. And maybe you noticed that right from the beginning because all 4 of the original terms are divisible by q squared. But that's showing up now. So I'm going to factor that q squared out now. That's going to leave me with 3p minus 5 inside the parentheses. So our final factorization is q squared times 3p minus 5 times q plus 2. Factoring by grouping on this page. Next up, well, this is not as bad as it looks because the lead coefficient is 1. It's not as bad as the other ones anyway. So when the lead coefficient is 1, we can just look for factors of c that add up to b, factors of negative 19 that add up to 18. And since 19 is a prime number, that makes things pretty easy. J plus 19 times j minus 1. 19 times negative 1 is negative 19. 19 plus negative 1 is 18. So pretty simple factorization there. Lead coefficient isn't 1 on the second example, but all 3 terms are divisible by 3. So that's where I'm going to start. Take it, factoring out a monomial of 3. H squared plus 23h plus 22 on the inside of the parentheses. Now that trinomial does have a lead coefficient of 1, so we can look for factors of 22 that add up to 23. Again, pretty simple at this point. H plus 22 times h plus 1, as in 22 times 1 is 22, 22 plus 1 is 23. So 3 times h plus 22 times h plus 1 is the complete factorization of that trinomial. And the coup de grace here, so to speak, of the last one, a lot of stuff going on. So the lead coefficient's not 1. Is there a greatest common factor I can take out? Yeah, all 3 of those terms are divisible by 4. So that's going to be 2z squared plus 9z plus 9. Now we run into trouble because this trinomial on the inside, it doesn't have a lead coefficient of 1, and it's not even a perfect square, which means we're not going to be able to use one of our perfect square or one of our special cases. So what I have to do is take that 2 and that 9, the a and the c value, and multiply them together. And I'm going to look for factors of that product that add up to 9. Factors of 18 that add up to 9. Well, 1 and 18 doesn't work. 2 and 9, those don't add up to 9. But 3 and 6, those do. So here we go. I'm going to take and break this trinomial up a little bit. 2z squared plus 3z plus 6z plus 9. So what I did was take that 9z and broke it up into 3z plus 6z. Right there, the 3 and the 6 that were factors of 18. Now I'm going to do some grouping, because now we got 4 terms we're going to factor by grouping. So 4. Then I'm going to use some brackets here to start breaking things up a little bit. 2z squared plus 3z, well, that'll be my first group. And my second group will be 6z plus 9. All right, in the first group, is there a greatest common factor I can take out? Sure, they're both divisible by z. That would leave me with 2z plus 3 inside. In the second group, is there a greatest common factor? Sure, they're both divisible by 3. When I factor that out, that would leave me with 2z plus 3. All right, so actually I'm done. At this point, I can write my final factorization. One of the factors is 4. Another factor is z plus 3. And another factor is 2z plus 3. A lot of stuff going on there. Of course, it could be even more, to be quite honest with you. But I don't think that's going to show up in this skill. Skill 8 in IXL's section AA of Algebra 1. Factor polynomials. Again, I wouldn't bother with this until you've mastered skills 1 through 7 because there's a lot going on here. And you have to kind of be very proficient at those before you can start trying to do them in combination with each other. Good luck when you do, though.